For this part of the lesson, we're going to focus on what are called composite shapes, how to find areas and perimeter of those, and then we're going to do some work with shaded parts of areas, so kind of a busy time for us. So first off, a composite figure is basically something that can be broken into regular shapes. So for example, this is kind of a weird shape. This is not a recognizable shape, but you can see that you can break it apart kind of into like a half circle and a rectangle. And for this one, you could break it into a triangle and a rectangle, and those do have formulas. So that's kind of how we work with composite shapes. So again, you can freeze the video to copy this down. I'm going to just go through it quick. When you find areas, you need to break it apart into regular shapes that have formulas. You need to make sure you have the correct dimensions of each section, and then you're going to add them together after you find each area. For perimeters, you do no breaking at all. You're just going to do simple subtraction to find the missing lengths of each side, and then you're going to add them together. So we'll do an example of area of a composite shape, and then we'll do an example of perimeter. So for this area, there's a couple options. You could go across here like this, or down here like this. It's not going to matter, so I think I'll just go kind of down for right now. You'll get the same answer either way. Obviously, you want to break the triangle away and make it into a triangle, a rectangle, and a rectangle. So what I'll do is I'll call this section A, we'll call this section B, and we'll call this section C. All right. So we need to get the areas of all these sections. So section A, section B, and section C. Once you get those areas, you can add them together. All right, so if you look at section A for right now, the width of the rectangle is definitely 5, so that's a true dimension. You don't want to use 6 for the length because, as you can see, that is not the whole length of the rectangle. So you actually would use 10. So we're going to do 5 times 10. All right, section B. So it's a little confusing. You have 15 and 7. You have to remember 15 is this whole bottom. Okay. 7 is just for this part, and that is the true length of letter B's rectangle. So all you need to know now is how high that rectangle is or how wide it is. So what you kind of do is you realize this whole side is 10, up to here is about 6. That means this is a 4, because together they have to make 10. So now we're going to do 7 times 4 and get 28. Letter C is still going to have a height of 4, so this is a rectangle, but you need to figure out the bottom right down here. So the key is noticing the whole bottom is 15. So you're going to start with 15 and you're going to need to subtract stuff off of it. So we need this part. Anything to the right of this line is not needed. So the 7 needs to go away. That's not part of our base anymore. And then it goes over 5 more. So we're going to do 15 minus 7 minus 5, and we're going to get 3. So this little piece right here is 3. So our triangle is going to be 1/2 times base times height. Okay, and that's what we're going to work with. Now, you don't want to pick up a calculator for this. When I do this problem, I think, what is half of 4? And that's 2. Then I'm going to multiply by 3, and I make that 6. So my area is going to be 50 plus 28, which is 78. 78 plus 6 is going to be 84 square inches. All right. For the next composite shape, we are only doing perimeter, so you literally need to have each side labeled for this. So your mission is to figure out what it is from here to here. Well, up top, the whole thing is 15. Part of it is 6. So 15 minus 6 is going to be 9. So that's our bottom. So I'll just kind of erase these lines for right now. Now I'm going to look going upwards. I know that here to here, the whole thing should be 10. And this portion is 4. So I'm going to have to do, oops, that's supposed to be an arrow. I'm going to have to do 10 minus 4, which is 6. So now we're going to add all of our sides together because every side has a label. And let's just start with 15. Now when I add sides, I actually draw a line on that side so I know that all of that perimeter right there has been accounted for. Now I'm going to keep going and I'm going to include the 10. I'm going to go again and I'm going to include 9. Again, 6. And then another 6. And I'm going to finish up with 4. So you should be able to easily see that we made it the whole way around by adding these sides together. So you can add however you want. I would probably do 10, 6, and 4 first just because I know how that makes 20. So 10, 6, and 4 make 20. You got 15, you got 9, you got 6. I know 9 plus 6 is 15. 20, 15, and 15. 15 plus 15 is 30, plus 20 is 60. So however you want to do it is fine, but the answer is going to be 60 yards. Make sure you have your units. So what we like to do is kind of go from composite shapes to shaded regions. Is to find the area of the whole figure. Okay, so the biggest shape that you can see in the picture, find the area of that. You're going to subtract the area of the non-shaded portion. Okay, and so we're going to write area of the big picture minus the area of the small picture. So that will be the whole image versus the white portion, and that will give you your shaded. So if you look at this big circle, its radius goes from the center to the end, and that is 6 centimeters. So your area is going to be 6 squared pi, because that's the formula. Now you're going to look at the small white circle, the one that's not shaded, and its radius goes from here to here. And it says right here that that radius is 2. So we're going to do 2 squared pi. Do a little cleaning up. This is 36, and this is 4. And you actually want to treat pi like it's an x. So if you were doing 36x minus 4x, it would be 32x. The only difference is this is pi. And then you don't want to forget your units, so it's going to be square centimeters. Done. The next figure consists of 2 squares. So you're going to do the area of the large square minus the area of the small square, or the non-shaded. So the first one's going to be 8 squared. The second one is going to be 4 squared. That becomes 64 and 16. And then 64 minus 16 should give you, I believe, 48. Now there's no units here, so all you want to do is just write square units. So we're going to finish up the lesson with 6 problems. If you want to try them on your own, go right ahead and do that. I am going to go through them one by one. So radius is 13. That means the diameter is 26. So your area is going to be 13 squared, or 169 pi, and it's going to be square inches. Your circumference is simply diameter, pi, and you're done with the circle. So circles should not take us long. So in this next problem, just to clarify, you know that this whole side is 20 because it's a rectangle. And I told you that these little pieces right here are 4 and 3.5. So that would mean that from here to here, you'd have to do 20 minus 4, which is 16, minus 3.5, which is 16 minus 3 is 13, so this would be 12.5. That'll be important later. So we're going to get the area of the large, of the entire rectangle, minus the area of the white portion, or the small. So the large, you're going to do 40 times 28. And then you're going to do 5 times this side, which we already found out was 12.5. So this is going to get you 960. 5 times 12 is 60. Plus 2.5 would be 62.5. 97.50. Okay, and then we just want to make sure we have square feet in our answer. And we're done. This next problem, you actually need to add in that this is also 3. That's something I forgot to do. So both sides are 3. So the area of this triangle is going to be 1/2 its base. So the base isn't 3, it's actually 6 times the height, which is 8. And then half of 6 times 8 is going to give you 24. For perimeter, there's no formula. You just go around, you're going to add 8.5, 8.5, and then the bottom, which is really just 6. So 6 plus 17 makes 23. We're going to cross out number 4 because we already did that on the front of this packet. Number 5, there's 2 ways to do it. You can break it going left to right or up and down. I'll just go left to right for now because I feel like that. So you have 2 rectangles. You have this one, which we'll call section A, and we have this one, which we'll call section B. So B's dimensions are going to be 28 and 13. A's dimensions, you got to be careful. It is actually 18 inches long, but it's definitely not 24 inches long. It only goes from here to here. So we're going to have to do 24 minus 13, and we get 11. So each side is 11. So then we're going to do 18 times 11. So if we do 28 times 13, we get 364. 18 times 11 is 198. 198 plus 364 gets you 562. And that's square inches. Okay, so that's the area. You also need to get the perimeter. So if you go around, the sides are going to be 18, 24, 28, 13. This little side right here is going to be 28 minus 18, which is 10. And then you have 11. So you have to add all those things together. And the perimeter is going to be 104 inches. Last but not least, in this problem, remember area means length times width. So x plus 7 times x plus 2. Now you guys should have learned last year that you need to do this little thing called FOIL. So you kind of distribute the x to the second parentheses, and that gets you x squared plus 2x. And then you distribute the last item, 7, and you get 7x and 14. And then you're supposed to combine like terms, so you get x squared plus 9x plus 14. Perimeter is actually going to be pretty simple. We're just doing 2 times x plus 7. We're going to add that to whatever 2 times x plus 2 is. So again, if you go through and simplify this, you're going to get 2x plus 14 plus 2x, plus 2, plus 2x plus 4. And that makes 4x plus 18. And since there's not units, we'll just write units, and this one we'll do square units. And that's it.